Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 20, Stoichiometry, Part 1. Here are our objectives for today's video. So you may have noticed that this chapter is titled Stoichiometry, which if you did not already know what that means, it's very, very similar to dimensional analysis, except it is mixed with balanced chemical equations, which we're going to build up to over the course of multiple videos. So before we actually get into what stoichiometry is, we need to do a couple of different types of calculations. And the first is analysis from a mass spectrometer. So a mass spectrometer is an instrument that pretty much tells you the molar mass of either all of the isotopes in a sample of like a specific type of atom, or it could tell you the molar mass of a molecule as well, which we'll talk more about later. For right now, we'll just talk about atoms. That's just thunder in my background. Hopefully I don't lose power. Pause here. Right, so this is actually really more of a math problem than this is anything else. So I'm going to show you how to set up this algebra problem if you didn't already realize it. So I'm just going to call X the prevalence of the isotope that has a mass of 152. I'm just going to call it X. And then 1 minus X is going to be the prevalence of the one that has a mass of 157. The reason why is because if I only have two isotopes, when I add their prevalences together, which prevalence is just another word for percent, it has to add up to 100% or 1. So now I'm taking the average mass. So 152 times its abundance, which is X, plus 157 times its abundance, which is 1 minus X, is equal to the mass that was given. And then from here, you just have to solve it algebraically, which I don't think that's going to be the hard part for any of you, really. So once you get X, so the prevalence of X, which you could either leave as 0.74754, or I like to do it as a percentage, but again, you could have left it as the decimal and it would have been fine. And then I just do 1 minus it to get the percentage of the other one. And these are not sig fig problems because these are really treated as sort of constant. So you could have rounded differently and that would have also been correct. Pretty much every sort of mass spec problem is going to be similar to this. Pause here. All right, for the remainder of this chapter, we're going to be referring to moles of atoms or molecules. So it was originally defined as being exactly 12 grams of the isotope of carbon that has a mass of 12. But you're not going to really need to use that super frequently. It's more frequently referred to as being 6.022 times 10 to the 23rd of something. So it could be atoms, could be molecules, could be other things, but you won't really see it very frequently. And that number is just called Avogadro's number. He's the guy who came up with this. All right, pause here and take a moment to try it. Make sure you've got your periodic table out. All right. So this is really just a dimensional analysis. But if you didn't already know this, you're going to have to go to your periodic table, find aluminum, and the mass that's listed on the periodic table is the mass in grams of 1 mole of aluminum, or really any element for that matter. So I have 1 mole of aluminum over 26.98. You could have included all the numbers. I am okay with you just rounding to 2 decimal places. And then because 16.3 has 3 sig figs, so my starting number, not my molar mass, that is going to determine the number of sig figs I end with. So that's why I get 0.604 moles of aluminum. Pause here. All right, I'll work through this one. It's very similar. So So this time the 26.98 grams goes up top such that moles can cancel with moles. I round it to two significant figures. And pause here. So this is very similar to the other questions. The only difference here is that you're also going to need to add on Avogadro's number. Before I can use that, though, I need to convert grams to moles. And then I can use the relationship that 1 mole is equal to 6.022 times 10 to the 23rd of something. This in my calculator, and then I round to 3 sig figs. I'm going to leave it in scientific notation because that's a whole lot easier than not. And I would really recommend that you put Avogadro's number in your calculator as the letter A. That's what I do. It'll just save you some time, although you don't really have to, especially if you don't have a graphing calculator. All right, that is all for today's video. Thank you so much for watching and have a great night.